What do you think is easier? All right, so number 9, like I said, there's 2 ways to do this. In my problem, this is what I was given. Something's fired at an angle of 32.14 degrees, or just 32.4, it doesn't matter, 32.4. And this is its velocity, 1,510 meters per second. Here, what it asks for is the amount of time it spends in the air, right? Okay, let me show you one way to do this, and then I'm going to show you the other way, and we should get the same equation. All right, here, this is the way that Quest explained it. They did it. I think this is the more, I wouldn't say easier, this is the more intuitive way of doing it. Okay, so a couple things we can say about this. We can use half the flight to kind of simplify this, right? Yeah. What do we know about t then if we're using half the flight?
Half the time.
It's going to be 2t, right? Because it's symmetrical, so the time it takes to get to its max height is going to be the time it takes for it to fall. So to get our final answer, it's going to be 2t, right? Times 2. Here's a couple things that we can assume. Vi in the y direction is equal to what? No, Vi, not Vf. Vi, what? Yeah, SOHCAHTOA, right? Because we have to break this up into components. So Vi in the y direction is going to be our initial velocity. I'm just going to use v, right? Our initial velocity sine theta, right? Okay. That means Vi in the x direction is going to be v cosine theta. Right? Those are 2 statements we can make based off of trig.
Wait, is your sine bigger than your velocity?
No, it shouldn't be. No, you did something wrong. Okay, then we can look at this equation. We can say that final velocity is equal to initial velocity plus acceleration times time. We can look at this equation, so we can say that we know this velocity doesn't change, it's constant. Okay. What are we going to look at here since we're splitting this in half? Which direction are we going to use to try to solve for time? We're going to use y. Okay, so I can add a y to all these things. Why are we using the y direction? Yeah, we're trying to solve for time, but there's something that we can assume here.
Maximum height.
Zero.
Maximum height, what's 0?
Velocity.
This. Final velocity, right? Okay. So this is 0. Well, it doesn't disappear. It's 0. Okay, so that's why we're going to be looking at the y. So we can say 0 equals, right? We said that VIY is equal to this, v sine theta, plus a is a constant, 9.8 t. Okay, so we would rearrange this for t. We get t is equal to, where is it? Yeah, v sine theta. All right, I'm just ignoring the negative, all right, for now. We know that if it's, no, not on this one. V sine theta over g, which is a, right, 9.8 meters per second squared. But since we're looking at half the distance, we have to throw a 2 out there. So the time it takes for it to fly through the air is 2v sine theta over g. Right, that's one way you can get to this. The other way I showed you is by factoring. Right? I think this is more direct because there's less assumptions this way, but the algebra is harder. So look up here. I want you to see both ways because one way is probably going to work better for you than the other. Here's the other way. So in this one, I can look at the object's entire path. Right? And I don't have to make any assumptions. I don't have to assume that VF at max height is 0. I don't have to assume that the t, half of t is equal to the full thing, all right? For this one, I can just do this. Delta y is equal to VIT plus 1/2 AT squared. Right? This only works in the y direction because the y has some acceleration going on. Okay, so this is a parabola. So over the entire course of flight here, what is delta y? This is 0. Okay. So I can say 0 equals,
You can throw out,
VIT plus 1/2 AT squared. Okay, we know that VI from our first part, we know that VI in the y direction is going to equal V sine theta. Okay. So substituting in here, I get 0 equals V sine theta t plus 1/2 AT squared. To make things a little bit simpler, what I'm going to do is multiply through by what?
2.
Times 2. Okay, to get rid of that half. So everything in times 2, I'm still going to get 0 equals 2 V sine theta, t plus 1/2, not 1/2, plus AT squared. Okay, and then here's where the factoring comes in. I can pull out a t from both sides. I hate this projector already. Pull out a t from both sides, and it'll look like this. 0 equals t times 2vi plus at. Sorry, not. Forgot that we already put in our sign. So 2v sine theta plus at. Right. And from our factoring rules, we know one solution is going to be t equals 0. The other one is going to have to be this 2v sine theta plus at equals 0. Solving for t here, what do we get?
You get a -2.
Yeah, let's ignore the negative for now. 2v sine theta over. That's the exact same thing we got the first time. So just another example of how in physics there's multiple pathways to the same solution sometimes. I would choose the way that makes most sense to you. Since I'm very familiar with this content, I can make, let me go back a couple slides. I can make these assumptions very readily, right? I can split my path in half. I can say that if I solve for t halfway, then I multiply by 2 at the end to get the full amount of time. I know that VF is equal to 0 meters per second in the y direction here. Right? But that's because I'm very familiar with this content. Some of you may be able to do that. Right? Those are things that you can remember. Others that are more the math heavy students, this is probably better for you, honestly. Because the only thing, actually I don't have to make any assumptions in this. All I do is, this is my equation. I know that in the y direction, this is what VI is equal to. I plug in, factor out t, and solve. So really just choose the one that makes more sense to you, I would say. Because that's a pretty common thing, solving for light time. Sorry?